So we're asked to use the remainder estimation theorem to prove that this Maclaurin series converges. And we do that by taking and first of all converting the cosine to its Maclaurin series representation. 1 plus, minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, so on and so forth. All right? So far, so good?
Yep.
All right. So what we'll need to do is we recognize that going out n terms that we get a piece of n, and that the remaining terms represent the r sub n, the remainder. Right? Now, r sub n is equal to the value of the it's equal to the value of the n plus 1 derivative at some value c times x to the n plus 1 all over n plus 1 factorial. If I remember the remainder estimation, and c is some value. C is some value between the center point A and the point X that we're checking. So what do we know about this? Well, we know that this function, this n plus 1 derivative, is bound. It doesn't get any bigger than 1. It doesn't get any smaller than negative 1. So really, whatever this expression is, and I didn't do this in class this way, but I think it's appropriate, this expression is sandwiched between negative x to the n minus, negative x to the n plus 1 over n plus 1 factorial, and between positive x and then what do we know? Now I might ask, well, what's the limit? As n approaches infinity of negative x to the n plus 1 power over n plus 1 factorial. And the answer to that is it's equal to 0. And the reason that is because x to the n gets dominated by n plus 1 factorial. And the factorial just grows so much faster. It eventually goes faster. We've seen for very large x's you have to go very far away, but eventually I can always find an n value which will make the factorial bigger, and when it gets bigger faster, and it'll drive that to 0. And of course, this is also equal to the limit as that approaches infinity of the positive version, and by our favorite sandwich theorem, brought to you by Ernie's. That would have to mean that this limit, therefore the limit of, as n approaches infinity of r sub n, is equal to 0. And if the remainder is 0, that means that the series must converge. And there you have it.
This number wag.
Okay. But the big point is, remember, the crux of this argument's got to be, no matter what x you choose, at the end of the day, factorial dominates. It's not, factorial never lets its teammates down. Always does the best job.
LeBron doesn't let his teammates down.
It's like Marshawn